Okay, so today we will start the student T test. How do we analyze data using the student T test? Let us first get to the definition. Student T test is a statistical analysis to find out the difference of one specific characteristic or variable between two groups by comparing the average value or mean. It means you have two groups that you are comparing, and then you will compare their average values or characteristics. It means that you will collect continuous variables from two groups, not categorical variable. You will get the average of their continuous variables, and then you will compare them. For example, you want to compare the height between male and female. It tries to answer, is there a significant difference between the average of two groups? It means you want to find out if the female and male groups have difference in their average height. It also answers, is it just random that their average height is different? Or did we make an error in choosing who to include in the groups? For example, did you had a bias because you have favoritism in selecting members of the group? For example, you get the average height of the male group from basketball players, and then you get the average height of the female group from the general public. Or it could be the other way around. So with that, you are committing a sampling error. The t-tests have two types. The first one is Unpaired T Test or Independent T Test. This is the test when you are comparing two different groups. By definition, you are contrasting two different, two independent, or two unrelated groups. For example, between male and female group, or between rural and urban dwellers. They are different and unrelated groups. When we are performing independent t-tests, we will always do first the null hypothesis. The symbol of the null hypothesis is H sub O, and the null hypothesis statement is there is no significant difference between the means or average of the two groups. For the alternate hypothesis, it can be H sub 1 or H sub A. There is a significant difference between the two population means. The difference is unlikely caused by random chance or sampling error. Now, when we are comparing unpaired t-tests, we have lists of assumptions. But in this video, we will not strictly follow the assumption because we will not be publishing this research. However, these are the lists that we need to follow when doing the unpaired t-test. The first one is the variable follows a normal distribution curve. Earlier I said that we need continuous variable or categorical variable. So it should follow a normal distribution curve or it has a shape like one. Second is the observed measurement is independently sampled. It means you have no bias. It means you did not choose a group like having members as basketball players rather than the general public. The variable is a ratio or interval. This is what I have been saying earlier, that the variable is not categorical, but it should have specific numerical values. Both groups have the same standard deviation or variance. So it means that when you plot their normal distribution curve, they have the same spread and same shape. But we will not follow this because we will just be doing this as an exercise. The two groups are independent of each other. Another kind of t-test is the paired or dependent or correlated t-test. This is where you are comparing the same group of people. For example, you want to know the effect of menopausal status of women on their bone density. Bone density is important because it gauges the risk of osteoporosis and other risk of spine fracture. This is the keyword, same group of people. In this example, our group is women, but they are differing in their menopausal status. One group is already menopause and the other group is still menstruating. They are the same group or people, women, but have different health conditions. Comparing items that measure same variable, for example, digital versus manual sphygmomanometer, the device used in measuring blood pressure. Is there a difference in the reading if you use digital versus manual sphygmomanometer? The device used is measuring blood pressure. Is there a difference in the reading if you use digital versus manual sphygmomanometer? Which of them is more accurate? Is it the manual or the digital device? Another example is being subjected to same condition. Like two groups are taking medicine or belonging to treatment procedures like surgery. So it is the same person, but they are receiving different modes of treatment. It could be that one group receives an effective drug and the other group receives placebo. Our null hypothesis should be stated as there is no significant difference between the means or the average of the two groups. The alternative hypothesis would be there is a significant difference between the two group means. The difference is unlikely caused by random chance or sampling error. Just like the unpaired test, we also have assumption with paired T test. The variable follows a normal distribution curve. The measurement is independently sampled. The variable should not have any outliers. The variable should be continuous, ratio, or interval. And the two groups are related to each other or match pairs just like the group of women in our example above. For this video, we are going to use a dataset that I got from this web page. It is about HL7 and the file name is diabetes rct180.csv. CSV means comma separated values. This file has 181 rows because the first row has the headers or the names of the variables. In the end, it is 181, but overall it is only 180. You can get the dataset from there. Since the headers are quite confusing, what I did was I changed the headers. I changed ID to patient ID, status to civil status, HA1CO 612 to HbA1c initial 6 month and 12 month. How do I know all of this? So I've been doing analytics for a long time now, especially in healthcare datasets. So I already knew how to get a shortcut in naming variables. HA1CO 612 was changed to HbA1c initial after 6 months after 12 months. SPP0 612 systolic blood pressure initial after 6 months after 12 months. ASA0 612, so aspirin initial after 6 months after 12 months. Aspirin is acetylsalicylic acid. It is the correct pharmacological term, I think. Path race is patient race, I think, so I just put it as race. Path gen is gender. Edu is education level. Income is income brackets. For Dur-Dice, I think it is the duration of the disease. I just changed it to diabetes duration. ENR INSU, I'm not sure, but I just changed it to insurance. Age is age. For BMI, I just expanded it to body mass index. So body mass index is the proportion of height to weight. Literacy score, I'm not sure what they mean by this. They might have tests for an IQ score, maybe. Literacy, this is the level of literacy which I presume is what they have finished in school. Is it elementary, high school, and so on? For this one, I'm not sure what they meant by this, but I just copied it. The same with this one diff, the difference from the 12th month HbA1c minus the initial level. With that, we can now open the orange. This is the default look of your orange. You can create a file, you can right click file, then you will go to your dataset. So this is the dataset I edited that we will use. Not this one, okay? You can also click the file, then drag to the widget. So this is the file widget will have the same dataset that we want. We will remove the other widget. And then we will rename this one to diabetes. Once you have the file loaded, just check its inside content. So here are the list of the variables or feature. So let us check. Civil status, okay, categorical, HbA1c level, it is a ratio or interval, systolic BP, aspirin. I think this one is categorical. 0 means they did not receive aspirin, and 1 means they had taken aspirin. Race, okay, categorical. Here I think what they did is white and non-white, I think. 0 is white and 1 is non-white. It could be African American, Asian American, etc. For gender, 0 means male, 1 means female. For civil status, 0 means single, 1 means married. This is just an assumption. The dataset has no description. If you will go to this website, there is no description of what the categorical numbers mean. Age, it's numeric. Insurance, categorical. Does he have an insurance or not? Let us check later which one is possible. Body mass index, it is the ratio of height and weight. Literacy score, it could be that they administered an exam which generated the score. For literacy, I'm not sure. Okay, it looks like everything is fine. Let us click apply. Okay. So let us save this as t-test. Then we check what is its summary statistics. You have the file widget, click this area, then drag to the right. Then a pop-up will appear. We will type feature statistics. You can move it to wherever you want except on the other side because it looks counterintuitive already. Feature statistics, this is what it looks like. This patient ID, we will not be focusing on this because it's just a patient ID. Let us put a color. So this is the mean. Remember, in t-test, it is the mean that is being compared between the two groups. Dispersion could be your variance or standard deviation. You have the minimum value, you have the maximum value here. Everything looks okay. Civil status, only 2 category, single or married. Aspirin, did they receive aspirin or not? Race, white versus non-white. Gender, male or female. Education, it could be no formal education, elementary, high school, college, postgraduate. Income, I don't know this, they might have used an income brackets. Insurance, no insurance, with insurance. So that is all our overall feature statistics. Next, we go to our data table. Here is where you will see the null values. Null values means that their values are not recorded. Now we proceed on how to perform the student t-test. Let us do the dividend plot first so we can see the two groups we are comparing. We click this and then link data to data. When we look at the Dividend Plot, let us just check. This is the area where we are looking for the mean. Click Initial HbA1c, then Civil Status. As you can see, it has outliers. Here, also outliers, and here. BP also has outliers. So remember, if there are outliers, we cannot use them for the paired T test, but we will disregard the assumptions for now. Let us perform the T test. Just click here and drag to the right, then click Box Plot. Select Data to Data, then OK. So in the box plot, it is easier to perform T test in Orange Tree software. Here above is the variables. Just choose the one with continuous variables, for example HbA1c initial. And then below is the group that you will be comparing. When you analyze this box plot, the yellow line, that is the median value of the group. Civil status, 0 is single. This is the median value for single. And then this is the median value for the married group. It is in this area. For the mean, here it is. They almost have the same mean. You will put an annotation by clicking here. When annotated, single have a mean value of 10.774 plus minus. This is the dispersion. For married, the average value is 10.781 and the dispersion is plus minus 2.17. So here is the automatic result you will see. You have a sample population of 180, you have a p-value of 0.984, and you have t-statistics of 0.02. So let us go back to our slides. I prepare here a question. Is there a difference in the average HbA1c level between single and married? Our null hypothesis is there is no statistically significant difference between single and married patients. Our alternative hypothesis, there is a statistically significant difference between single and married patients. When you stated your hypothesis like that, you can just basically copy the result from the box plot. Okay, take screenshot, copy, paste. So our result is T test statistics 0.02, p-value is 0.984. Assuming that our alpha level is 0.05, the p-value is bigger than 0.05. So we decide to not reject the null hypothesis. Our conclusion is there is no statistically significant difference between single and married patients. So that is our first t-test that we performed. Okay, after our fast forward, making hypothesis, trying to input data from orange tree, let's now analyze the data. I made some changes here. So let us discuss. So our first inquiry is there a difference in the average HbA1c level initial between single and married patients? Our null hypothesis is there is no statistically significant difference in the average HbA1c level between single and married patients. Our alternative hypothesis is there is a statistically significant difference in the average HbA1c level between single and married patients. So the single group is this one. The yellow bar is the median. So as you can see, we have outliers. The gray line is the average. For the single group, the average HbA1c is around 10 with dispersion of 2.62. For married, it is 10.781 with a dispersion of 2.17. The p-value we got is 0.984. It is bigger than our alpha of 0.05. Our decision is to not reject the null hypothesis. It means that the null hypothesis is true. We conclude that there is no statistically significant difference between single and married patients in terms of average HbA1c level initial. Next, is there a difference in the average HbA1c level between white versus non-white? Null hypothesis, there is no difference. Alternative, there is a difference. 0 is white, the average is 10.575. The average for non-white is 10.876. The p-value that we got is 0.372, which is bigger than alpha, so we will not reject the null hypothesis. Our conclusion will be there is no difference in the average initial HbA1c level between white and non-white. Next, is there a difference in the average initial HbA1c level between male and female patients? Null hypothesis, there is no difference. Alternative, there is a difference. Here in our box plot, 0 is male. Their average is 10.544 with a dispersion of 2.16. 1 is for female. Their average is 11.129 with dispersion of 2.69. You can see the average of the female group is bigger than the male, but is it statistically significant? Our p-value is 0.124, which is bigger than our alpha of 0.05. So we will reject the null hypothesis and we can conclude that there is no difference in the average initial HbA1c level between male and female patients.